Hello friends and students, welcome to all for today's session, Basic of Belt Drive. Myself Professor Kushare. Today we will discuss basics of belt drives. Belt drives are flexible drive generally used to transmit power between the two shafts by frictional grip or frictional resistance in between pulley and the belt. When there is a proper frictional grip, then and then power is transmitted from driving pulley to the driven pulley. Belt drives are also known as flexible drive because the material used for the belt, which is flexible or somehow elastic one. Because of that, belt drives are also known as flexible drive. Chain drive is also a flexible drive. Belt drive consists of following elements: driving pulley, driven pulley, and endless belts. Three important elements. Belt drives are having following advantages. It can transmit power over considerable distances. In case of flat belt up to 15 meter, and in other cases up to 3 meter. For or Vbelt drive can be used up to 3 meter. Then belt drives operation is smooth and silent. This is one of the advantage of belt drive. Then it can transmit only a definite load and slips over the pulley when this load exists, and because of that it protects the parts against the overload. This is also one of the advantage. Slip is having advantage in this case to protect the parts against the overload. But in some of the applications, slip is a disadvantage or limitation of this belt drive because it doesn't provide constant velocity ratio. Then another advantage is ability to absorb shocks and damp out the vibrations. This is one of the advantage. And last one, belt drives are simple to design and having a low initial cost compared with other drive. Some of the disadvantages or limitations: it occupies more space. Then limitation is velocity ratio is not constant because of slip. Again, it puts heavy loads on the shaft. Another disadvantage, loss of power resulting in low efficiency. Loss of power, this is because of slip. And last one, service life is short. You will find belt drives are used in electric motors, automobiles, and machine tools and conveyors in day-to-day life application. Further, belt drives are classified into basically four types. One is flat belt, second one is V-belt, third one is rib belt, and fourth one is the tooth or timing belt. But today in basics we will see the flat belts and V-belts. Let us consider first one, flat belt. Flat belt is having a rectangular cross section. Again, it's cheap and easy to maintain, generally used for longer distances, and efficiency is more compared with the V-belt drive. Again, it is used in belt conveyor, baking machinery, brick and clay machinery, crushers, sawmills, textile machinery, line shafts, and bucket elevers. Why these flat belts are used in these cases? It can transmit power at longer distances. This is one, and second one can be used in open environment also or in dust environment also. That's why you will find the such a type of applications. Another type of belt drive, that is V-belt. The V-belt drive is having trapezoidal cross section, and V type of or U type or groove pulleys are used for this V-belt. Because of this, there is a proper frictional grip between belt and the pulley because of wedge action. Therefore, it transmits more power or more power transmitting capacity than the flat belt. Again, it can be used for shorter distances. Again, by using Vbelt drive, high speed reduction even up to 7 to 1 can be achieved. And these Vbelt drive are also known as a positive drives because slip is negligible compared with other drives because of this wedge action or proper frictional grip between belt and pulley. Vbelt drives are used to drive compressor, pumps, fans, positive displacement pumps, blowers, machine tools, and they are also popular in automobiles to drive accessories on petrol and diesel engines. In other cases, or these drives or compressor pumps are connected to the prime mover, that is electrical motor. Belt constructions. Belt drives generally constructed in 4 to 5 ways. One is open belt drive, second one is the cross belt drive, third one is the quarter test drive, fourth one is the belt drive with idler pulley, and fifth one is the belt drive with many pulleys. But in this presentation we will focus on open and cross belt drive only. Now here in open belt drive, you will find this is support driving pulley and this is another driven pulley, and belt proceeds from top of one pulley to the top of another pulley without crossing it in open belt drive. Second, both the direction of rotation of driving and driven pulleys are same, or they rotate in same direction. If driving pulley rotates clockwise, the driven member or driven pulley also rotates in clockwise direction. And when center distance is more in case of open belt drive, the belt whips or vibrates. This is limitation. Then another type, that is cross belt drive. In cross belt drive, belt proceeds from top of one pulley to the bottom of another and crosses over. Suppose this is this is driving pulley and another one, its construction is like this. That means belt proceeds from top of one pulley to the bottom here, bottom of the another pulley and crosses over itself. But in this case, both the pulleys rotates in opposite direction. In cross belt drive, because of this crossing, more the angle of wrap or contact between belt and pulley is more compared with open belt, and because of this power transmitting capacity is also more. But compared with cross, open belt drives are more popular. And another construction are there. Belt drive use many pulleys, then idler pulleys are used, but our focus is only on this open and cross belts. Now let us find out the belt length for open belt drive, because while specifying or while purchasing the belt from the market, we have to specify the belt length. This is one of the requirement. How to find out this belt length of open belt drive? First of all, open belt drive. Now here, this is driving pulley, it rotates in clockwise direction. This is driven pulley or larger pulley, is having diameter capital D, is having small d. Now here belt, this is belt which is wound over the pulleys. Now here you will find for smaller pulley, belt is in contact with this smaller pulley from this F up to this B, and this is total angle, that is 180. Now here beta is the angle, small angle. The 180 minus this beta, and this beta means 2 beta. So you will find angle of wrap for the smaller pulley 180 minus 2 beta. And for larger pulley, the belt comes in contact up to these parts, This is 180 and this is beta, and from this beta, for larger pulley you will find angle of wrap 180 plus 2 beta. 180 plus this beta, and this beta means 2 beta. Now here let us take alpha s. This is wrap angle for small pulley, which is 180 minus 2 alpha, and alpha b is the wrap angle for big pulley, it is in degree. This is 180 plus 2 alpha, already given here. Then second, capital D is the diameter of big pulley, small d is the diameter of smaller pulley, c is the center distance. Now to find out the belt length, draw a line which is perpendicular to this O1 to C through this hole, line is drawn perpendicular here, and it makes one rectangle, that is O, then G, C, B, and now this GC is equal to here radius of this smaller pulley. It will help in the analysis. Now let us find out sine beta. This beta is the angle. Find out the sine beta. Sine beta is equal to here O1G upon this O1 and O. Substituting their values, you will get sine beta is equal to capital D minus small d by 2c. It is sine beta. So we can find out here beta is equal to sine inverse of in bracket capital D minus small d by 2c bracket complete. And by substituting this value of beta here in the expression of angle of wrap for smaller pulley and larger pulley, we will get angle of wrap, that is 180 minus 2 beta and 180 plus 2 beta. After substituting these values, you will get angle of wrap for smaller pulley and angle of wrap for larger pulley. Then find out the length of the belt. Now length of the belt, here you will find, consider how much is the length, the arc FAB plus this length B2 up to C, then again arc CDE, and then length again E to F. So we have to add it, arc FAB plus length BC plus arc CDE plus length CE. After substituting these values of arc APB means R into theta, the D by 2 into alpha S, D by 2 into alpha S, plus OG bar is the length, then again another arc R into theta, that is D by 2 in alpha B plus OG. Substituting all these values, at the last we will get this expression. Again here for smaller values of beta, that is equal to sine beta D minus D by 2c, and cos beta is equal to 1 minus 2 sine square beta by 2. This is expression, geometrical relation or formula, we can use it. So you will get 1 minus beta square by 2. Substituting the cos beta is equal to this value here. Then substituting all these values, what you will get at the last, you will get the length of open belt drive L is equal to 2c plus pi in bracket D plus small d bracket complete by 2 plus capital D minus small d bracket square by 4c. C is the central. This is the length of for open belt drive. Open belt. Then again we can find out belt length for cross belt drive. Now in this case, in cross belt drive, you will find the direction of rotation of the driving pulley and direction of rotation. Now in this case, the driving pulley rotates in anti-clockwise direction and driven pulley, it rotates in clockwise. They are in opposite direction. Again second, they are crosses here. And the same analysis we can carry like a open belt drive. Just here we have to construct a line which is parallel to this FC and draw the perpendicular to this where it intersects to the G, and this is, it makes one rectangle here, this rectangle, and this distance C to G is equal to radius of this smaller pulley. And likewise we can carry out the same analysis. In this case you will find angle of wrap. Now contact between this belt and the pulley 180 plus this beta and this beta means 180 plus 2 beta angle of wrap. And for larger pulley also you will find this is 180, and again this angle is beta, this beta 180 plus 2 beta, which is for cross belt drive for larger pulley. That means for both smaller pulley as well as larger pulley, angle of wrap is equal to 180 plus 2 beta. And again beta we can find out from the sine beta is equal to, likewise open belt drive. And again length of the cross belt drive, again we have to consider the arc F to up to this point, then this length, then this arc, and then again this length, and adding and taking this arc is equal to R into theta, again here R into theta, substituting this length distance and this So we will get finally the belt length for cross belt drive. You can derive this expression like open belt drive. L is equal to 2c plus pi in bracket capital D plus small d by 2 plus capital D plus small d bracket square by 4c. Only there is a one small change, that is instead of having negative side here, plus sign in cross belt drive. Now another terms or basics which is required for selecting belts from manufacturer catalog, that is power transmitted by belt. Again here you will find belt is subject, already you studied in theory of machine, belt is subjected to a tension, and these tensions, belts is subjected to a tension, that is T1 and T2. T1 is the tight side tension and T2 is a slack side tension, and which is in Newton. And V is equal to velocity of the belt in meter second. To find out the power transmitting capacity of the belt, the effective driving or turning force at the circumference of the driven pulley is equal to T1 minus T2. Tight side tension is always more than the slack side tension. This is effective driving force, and which is multiplied by V. It gives the power transmitted by a belt. You should remember this term. Power transmitted by the belt is equal to T1 minus T2 into V, or F into V. F is the effective driving or turning force. Then limiting tension ratio for belt drive. Already you have derived this expression in earlier subject or course, that is theory of machine. Now tensions for flat belt drive or limiting tension ratio for flat belt, which is given T1 by T2 is equal to e raised to mu theta. Now where mu is the coefficient of friction between the belt and the pulley, and theta is the angle of contact between the belt and the pulley, angle of contact or angle of wrap, and generally it is calculated. Now here theta 180 minus 2 alpha into pi by 180, it is in radian. Again sin alpha is equal to R1 minus R2 by C, or in terms of capital D minus small d by 2C. In this fashion we can find out it, or 4C. Now here in this case, instead of in limiting tension ratio, alpha is taken, and in early expression of the length beta is taken. Try to understand, don't make any confusion here. The 180 minus 2 alpha into pi by 180. This is angle of wrap or angle of contact for the pulley. If pulleys are made up of different materials, belts are all different materials, then mu theta, how to which mu theta should be considered, so which is having a smaller value, mu into theta, that we have to find out, and that we have to take into design of the belt drive or in calculation. Try to understand. Then for cross belt drive, this angle of wrap is 180 minus 2 alpha into pi by 180 into rad. Here also instead of beta, alpha is taken. Don't make confusion, and this sin alpha or sin beta is equal to R1 plus R2 by C, applicable to cross belt drive. Then centrifugal tension. As the belt moves around the pulley, it would experience a centrifugal force, and which has a tendency to separate the belt from the pulley surface. But to maintain the contact between the belt and pulley, a known centrifugal tension gets developed in the belt, and which would be in addition to the tension required for power transmission, that is centrifugal tension. Let us assume Tc be the centrifugal tension on either side of the belt, and this centrifugal tension is given Tc is equal to mv square. Total tension in the tight side, that is T1 is the suffix, is equal to T1 is tight side tension plus Tc is added here, and total tension in the slack side, that is T2 is the slack side tension plus Tc. We know that the power transmitted by belt, that is P is equal to Tt1 minus Tt2 into V. Substituting these values here, at the last again here Tc gets cancelled. The P is equal to, you will get T1 minus T2 into V. Tc has, that means Tc has no effect on power transmission. Even though centrifugal tension is considered, it doesn't have any effect on power transmission. Then maximum tension in belt. Generally, in some of while solving the problems, you will find the term maximum tension in the belt. But this is maximum tension in the belt is equal to the total tension on the tight side. If centrifugal tension is considered, the total tension in the tight side is Tt1 is equal to T1 plus Tc. And if centrifugal tension is neglected, the total tension in tight side, that is T1, or total tension T is equal to T1, or T1 is the maximum tension in the belt when Tc is neglected. Try to understand this. Maximum tension in the belt is always tight side tension. Then another topic, condition for maximum power transmission. We know that the power transmitted by the belt is given P is equal to T1 minus T2 into V. But what is the condition to transmit the maximum power by using belt drive? Now again further, limiting tension ratio for flat belt drive is given by T1 by T2 is equal to e raised to mu theta. Therefore, T2 is equal to T1 upon e raised to mu theta. We can substitute the value of T2 in this expression. Substituting this value, we will get P is equal to T1 minus T1 upon e raised to mu theta bracket complete into V. Therefore, P is equal to T1 into V. Now here let us assume C is one term, that is 1 minus 1 upon e raised to mu theta for our derivation purpose. Further, we know that T1 is equal to T minus Tc. T is the total tension, T1 is the tight side, Tc is the centrifugal tension. Again, substituting the value of T1 in this equation, so we will get P is equal to T minus Tc into this V into C. Again, but Tc is equal to mu square. Therefore, P is equal to T minus mu square bracket complete into V into C. Multiplying by this V to these terms, the Tv minus mv cube into C. C means this term, 1 minus 1 upon u theta. To have a maximum power transmitting capacity, this equation is differentiated with respect to V and equating to 0. The dp by dv is equal to 0. Therefore, d by dv in bracket tv minus mv cube into c is equal to 0. Taking its derivative, what you will get? T minus 3mv square is equal to 0. Therefore, T minus mu square means Tc. 3Tc is equal to 0. So, what you will get? T is equal to 3Tc. This is one of the condition for maximum power transmission. Further, we know that T1 is equal to T minus Tc. Again, but we know that Tc is equal to T by 3. Substitute this value here. You will get T1 is equal to 2T by 3. This is the another condition. Further, from this equation, T is equal to 3Tc, but Tc is mu square. Therefore, T is equal to 3mu square. V square is equal to T upon 3m. So, we can find out V is equal to under root T upon 3m. This is another condition based on velocity of the belt for maximum power transmission. That means T is equal to 3Tc, V is equal to under root T by 3m, or T1 is equal to 2T by 3. These are the conditions for maximum power transmission. Then another important points, that is initial tension in the belt drive. When belt is wound around the two pulleys, its two ends are joined together so that it may move over the pulley continuously or without slip. The motion is due to the frictional grip between the belt and pulley. To increase this grip, initially belt is tightened up. Therefore, even when the pulley is stationary, that means is not in motion, the belt is subjected to some tension, and this tension is known as initial tension. Now here, what is the magnitude of this initial tension that we are going to find out? Let TO is the initial tension in the belt, T1 is the tight side tension, T2 is the slack side tension, and alpha is the coefficient of increase of length per unit force. Now increase in tension in tight side. So the maximum tension in tight side is the T1. And initial tension that we have consider TO. The increase in tension in tight side T1 minus TO. Therefore, increase in length by multiplying by alpha, you will get the increase in length of belt on tight side. Alpha in bracket T1 minus TO bracket complete. Similarly, another side is the slack side. In slack side, decrease in tension in slack side. That is TO is the initial tension minus T2 is the slack side tension. And decrease in the length of belt on the slack side multiplying by alpha, that is coefficient of belt length, in bracket TO minus T2. If perfectly elastic material is used for the belt, then this increase in length of the belt on tight side is equal to decrease in the length of belt on the slack side. Comparing these two equations, alpha in bracket T1 minus TO is equal to alpha in bracket TO minus T2 bracket complete. So what you will get, initial tension is equal to T1 plus T2 by 2. Even though by considering centrifugal tension you can add it in T1 plus Tc and here in this T2 plus Tc. So we can find out also T initial tension by considering centrifugal tension also. But this is the initial tension in case of belt drive without considering Tc, that is T1 plus T2 by 2. Then another term, ratio of driving tension for Vbelt or limiting tension ratio or Vbelt. I am not going to derive the expression for Vbelt. Already you studied in pbkushare courses, that is theory of machine. Now we are in Vbelt, V-grooved pulley which is used here, and there is a belt, and because of this wedge action from this side and this side there is a proper frictional grip. That's why it transmits more power than the flat belt or other drives. Again here R1 is this R1, this are on both the sides. Normal reaction between the belt and sides of the groove. Then R is the total reaction in the plane of the groove, and mu is the coefficient of friction between belt and the sides of the groove. And this limiting tension ratio for Vbelt is given by T1 by T2 is equal to e raised to mu into theta into cosec beta. Now here in this case theta is the angle of wrap, mu is the coefficient of friction between belt and the pulley, and here beta is this semicone angle of this groove pulley. Now here this is 2 beta. Generally this angle is 40 degree, but here while taking it we have to take semicone. So 40 by 2, you will get 20 degree here. Beta is equal to 20, or this expression can be written as T1 by T2 is equal to e raised to mu theta upon sine beta also, and 1 by sine means cosec beta. 1 by sine means cosec beta. Try to understand. And the value of this, half of this we have to consider. This is total 2 beta, half 2 beta. That means here you will get the beta that we have to substitute. Generally this value is 40. And if we are going to take this value is equal to 40, and any other terms remain same, mu into theta for a flat belt as well as the Vbelt, you will find the 2 to 2 point something % more power transmission than the flat belt drive. These are some of the basics or fundamentals which are related to the belt drives that we have discussed, and which will help you while selecting the belts from manufacturer's catalog. For the same, I have referred the book of V.B. Bhandari, Design of Machine Elements, McGraw-Hill publication. If you have any query, contact me at 9890426679 or pbkushare@kkvak.edu.in. Thank you.